Hey everybody, Mr. Troy here. It is time for us to start our examination of higher order polynomial functions. So bring your higher order thinking skills because it's time for math with Mr. Troy. All right, folks, a quick reminder from earlier in life. A polynomial function is something that has coefficients, variables, and exponents. Now, we're normally going to have our coefficients be real, although there are plenty of interesting things to happen with imaginary coefficients, and we'll surely check in on that at some point. The exponents must be whole numbers, and they cannot be negative. Our a sub n is going to be our lead coefficient, and our a sub 0 is going to be our constant term. You'll notice that all of these have an x except for a sub 0, and that's because continuing in the pattern, it would be x raised to the 0 power, and x raised to the 0 power is just 1. When we talk about higher order polynomials, that's going to be things with a degree greater than 2. Something with a degree of 2 is called quadratic. Something with a degree of 1 is called linear. And if all you have is something like y equals 5, then that would have a degree of 0, and it would be a constant function. Each term can be referred to by its type. So the x term would be the linear term. The term that has no variable would be the constant term. The x squared term would be the quadratic term, and so on and so forth. So two things to know. A polynomial function with a given degree has at most that many real zeros. So there are that many real numbers that could make it be equal to 0. And it has at most n minus 1 turning points. So that's why every quadratic we looked at in the last unit had 1 turning point, because its degree was 2. It could have 2 real zeros and 1 turning point. So this is a third degree trinomial. It's called a trinomial because there are 3 terms. It's called third degree because that's its highest exponent. A synonym for third degree is cubic, because a cube has 3 dimensions, length, width, and height. At most, this has 3 real zeros, and at most it has 2 turning points. Now, if something looks like this, we're going to refer to these as relative maxima or relative minima, like a minimum or a maximum. We're not going to refer to them as vertices or as a vertex, because they won't necessarily be in the middle of the function. So see if you can figure out all of that stuff for this one. All right, here's that information for this next one. It's 6th degree. It has 4 terms, so we don't call something a quadrinomial. After 3, we say monomial, binomial, trinomial, and then after that we just say 4 terms, 5 terms, 6 terms. This has at most 6 real zeros and at most 5 turning points. I'm going to introduce end behavior here just because we're going to talk about it a lot. So we're starting with a function that we know how to graph. So this is a quadratic trinomial, and we know that it has to look something like this. The reason that I know that it has to look something like that is because the y-intercept corresponds to the constant term, And then remember that this value tells us that the graph is decreasing through that y-intercept, or opposite of b over 2a would tell us that the axis of symmetry is 5/4. So that's a quick sketch of what that graph would look like. So end behavior is saying what happens to the graph as you approach this direction and as you approach this direction. So to the right, we say as x approaches infinity, what happens to y? Well, as we pick larger and larger and larger x values, this graph is going to go up and up and up and up. So we would say as x goes to the right, or as x approaches infinity, y also approaches infinity. Now what happens as x approaches negative infinity? So this is different from what you're used to, so make a mental note here. You are used to saying that this graph kind of goes from left to right. But we want to say here, what happens if you step this way, this way, this way, this way, this way, all the way to the left? Well, if you were moving to the left on the graph, the y values would continue to go up and up and up and up. So we would say also that y approaches positive infinity. For this unit, we're mostly going to be talking about negative infinity and positive infinity. We'll use different numbers later on in this class, and you'll also use different things in other classes. So you read this as x goes to infinity, or as x approaches infinity, y approaches infinity, or as x gets arbitrarily large, y gets arbitrarily large, or as x increases, y increases. Now, this is end behavior, because you could say, well, look, x is increasing right here. You know, you're going from -1 to positive 5/4, and the y value is getting smaller, but that's not the end behavior. We want to know what happens as we get arbitrarily far to the right side, not just moving from left to right. Cool. This is stuff that I'm sure that you've picked up before, but I just want to re-emphasize it. Saying that something is a zero of the function means if you plug it in, you get 0, which would show up on the graph as an x-intercept, or would solve the equation the function equals 0. Another synonym of that is that x minus a is a factor. Now you've seen this before when you've said x minus 2 times x plus 3 equals 0. So that means x equals 2 or x equals -3. But we're going to make a little bit more of a connection between those in this unit. So this is the one that's probably the most new. Okay, with all that out of the way, it's time for a skill. I love polynomial long division. It's just like long division, but better. Okay, so in polynomial long division, you are going to care about whatever the leading term is for each of the dividend and the divisor. So you're going to care about whatever the leading term is for the dividend, that's the thing being divided, and the divisor, the thing that is doing the dividing, the divider. So the dividend and the divisor. You're going to say to yourself, how many times does x go into 6x cubed? And at first, that seems really confusing. So think about it this way instead. What would I multiply x by to make it 6x cubed? Well, you would need a 6x squared. This is going to be our quotient. And we might also have a remainder. So when I multiply all of this out, that would give me 6x cubed minus 12x squared. As with all long division, I'm going to subtract now. But a new wrinkle to this is that we are subtracting multiple things. So we might need to think about subtracting a negative, for example. When I subtract, I'm going to get negative 7x squared. And depending on how many terms I have here, I'm going to need to bring some more things down. So since I have 2 terms here, I'm going to bring another term down. Just dropping it straight down like you do with division normally. Okay, now I'm going to say to myself, how do I multiply x to get negative 7x squared? Well, I would need to multiply by negative 7x. So you're saying, how many times does x go into negative 7x squared? But the answer is not just a number, it's a number and a variable. What do I multiply x by to get negative 7x squared? Negative 7x. So multiplying that all the way out, I would get negative 7x squared plus 14x. I'm going to subtract all of that, and I'm going to get 2x minus 4. Now, I can see that this just goes in twice, which is nice. This has no remainder, which means that it divides out evenly. So it has a remainder of 0. I find this division process to be extremely fun, which is probably why I became a math teacher. I get it. We can use this to write a statement. So the statement that we're going to write is that 6x cubed minus 19x squared plus 16x minus 4 equals x minus 2 times 6x squared minus 7x plus 2 plus 0. So the dividend, the thing that we started with underneath the long division bar, equals the divisor times the quotient plus whatever the remainder happens to be. This divides out evenly because the remainder is 0. Because this divides out evenly, that would have to mean that this is also a factor. More on that later. Okay, here's one more problem as practice to see if we can see how to do it. Try and stay as organized as possible, and even though I don't have the neatest handwriting in the world, I try and keep everything as organized as I can. So, we start by thinking about the 6x to the 4th and the 2x. What would I multiply 2x by to get 6x to the 4th? I would do 3x cubed. Notice how I'm putting that above my x cubes to try and stay organized? Okay, so multiplying that by my divisor, I would get 6x to the 4th plus 21x cubed. I'm going to subtract all of that here, and I'm going to be left with negative 26x cubed minus 127x squared. Now, to multiply 2x to get negative 26x cubed, I'm going to need negative 13x squared. Remember, you're just trying to match that leading term. And I think that gives me 91x squared. And I want to subtract all of that. Be careful to watch all of your minus and negatives. So this is going to give me 36 x squared minus 46x. I would need 18x to multiply into that. So that's going to give me 36x squared plus 126x. And I'm going to subtract all of that. That's going to give me 172x plus 280. Sorry, I misspoke here. Negative 172x plus 280. All right, you know what, folks? Sometimes this happens. I just caught a mistake, and lucky I caught it now instead of catching it later. I was trying to make negative 36x squared. I didn't watch my signs here. So therefore, this sign was incorrect. And I know you're saying, Mr. Troy, couldn't you just re-record the video? Well, of course I could. But then we would assume that I always get every math question right on the first try? I don't think so. Okay, so that's going to change all of these signs. So, to recap, there was a negative minus a negative situation here, and I had the wrong sign here, which led me to have 18x instead of negative 18x, which led me to do all this wrong. So, when that happens, if you catch it, you just have to go back and kind of fix your mistake. Hopefully you catch it before the end of the problem. So I end up actually getting 80x plus 280, which would need a plus 40. And then that means that this actually divides out evenly. Phew. Okay, so if you just asked me, hey, what is the answer to this problem? I would say that the answer is the quotient. If this had a remainder, I would say that it was the quotient plus the remainder. All right, folks, that's enough for one video. I will see you soon, where we will learn more about the wonderful world of polynomials. Here's my intro song to just kind of play you out.